The topic is multiplying whole numbers and area. The objectives in this topic are use the properties of multiplication, multiply whole numbers, find the area of a rectangle, and solve application problems by multiplying whole numbers. Multiplication is just repeated addition, but with different notation. For instance, if we had 6 plus 6 plus 6 plus 6 plus 6, that means that there's 5 sixes. Or we have 6 5 times. 5 times 6. We're adding 5 times 6. That's why we say 5 times 6. The 5 and the 6 are referred to as factors, and the answer to a multiplication problem is a product. So 5 times 6 equals 30. 5 and 6 give us a product of 30. The times, that x is called a multiplication sign. Now, get out of the habit of using the multiplication sign. You want to, whenever possible, try to use the dot instead. The dot also means multiplication. And we see that here in these multiplication properties of 0 and 1. So 0 was special with addition because anything plus 0 is itself. Both 0 and 1 are special in multiplication. 0 is special because the product of any number and 0 is 0. So 5 times 0 is 0. 0 times 8 is 0. It doesn't matter if the 0 comes first or the 0 comes second. If you're multiplying two numbers and one of them is 0, the answer is 0. That property actually turns out to be pretty important in algebra later on. Then there's the multiplication property of 1. Just like adding 0 to a number doesn't change it, multiplying a number by 1 doesn't change it. For example, 1 times 9 is 9. 6 times 1 is 6. It doesn't matter if that 1 comes first or if the 1 comes second. Either way, it does not change the number to multiply it by 1. So in A, what don't we like about that? We don't like that it says 4 cross for times and 1. And that's because we're going to be introducing x as an actual thing we need to work with, different from a multiplication sign as we move along. So the x just causes confusion when it's used for multiplication. But anyway, this is 4 times 1. Anything times 1 doesn't change the number, so this is 4. B, we don't have the x, we don't have the cross, we don't have a dot, we have a 0 and then in parentheses 5. Well, when a number is right up against parentheses, or in D, when parentheses are right next to parentheses, that means multiplication as well. So B says 0 times 5, and anything times 0 is 0. C means 1 times 52. Anything times 1 is itself, so 52. And D means 76 times 0. Anything times 0 is 0. And you can see it from just these examples. 4 times 1 would be the same as 1 times 4. 0 times 5 would be the same as 5 times 0. 1 times 52 would be the same as 52 times 1. And 76 times 0 would be the same as 0 times 76. Is it possible that there is a commutative property for multiplication as well? Sure is, and an associative property as well. Remember, the commutative property means we're actually moving them around. We're changing the order. 4 times 3 would be 12. 3 times 4 would be 12. For an associative property, we're changing the grouping. 2 times 3 times 4, it doesn't matter if we multiply the 2 times 3 first or if we multiply the 3 times 4 first. When we multiply by the third number, we're going to get 24 either way. There's a third property. This one isn't exclusive to multiplication, and it wasn't mentioned when we did addition because it involves both addition and multiplication. It's called the distributive property. Specifically, the distributive property of multiplication over addition. So if we have a 2 times in parentheses a 3 plus 4, for example, that's the same as taking the 2 times the first thing and adding the 2 times the second thing. So 2 times the quantity 3 plus 4 is the same as 2 times 3 plus 2 times 4. And you might be saying, well, why don't we just add the 3 plus the 4 to get the 7, and then the 7 times the 2 is the 14, as opposed to 2 times 3 is 6, and 2 times 4 is 8, and 6 plus 8 is 14. Why would we ever want to do this? Remember, I mentioned that x is coming. And we don't know what x plus 4 is, but we still have to be able to multiply it by 2. So we need something like this distributive property to get rid of parentheses and problems. So let's practice. Rewrite 4 times the quantity 5 plus 6 using the distributive property. It would have been nice if that animation happened in the other order, but so be it. The 4 times the 5, and then add the 4 times the 6. We don't need to simplify it. We were just told to rewrite. Use the distributive property to multiply 3 and 79. Well, here's a nice use for it that doesn't involve this x that's coming. 3 times 79, that's a big number. We actually don't know how to do that yet. Right now, all we're assuming is that we know how to do the basic multiplication table. 9 by 9, maybe 12, but we're just assuming that you know through your nines. By the way, if you don't know through your nines, make flashcards, get those memorized. Math is going to get hard without being able to do your times tables. 3 times 70 and 3 times 9, those are easier to do. We can write 79 as 70 plus 9 because that's its expanded form. So 3 times 70, that's 3 times 7 with a 0. 3 times 7, we know that's 21. 21 with the 0 is 210. 3 times 9, we know that one, that's 27. We add 210, 210, sorry, plus 27, and we get 237. Multiply 624 by 3. Don't worry, I'm not going to ask you, at least not yet, to do this using the distributive property. By the way, that would just be 3 times 600 plus 3 times 20 plus 3 times 4. We're going to go through the process of multiplying, quote unquote, the old-fashioned way. We will set up 624 times 3. The process is to take the number in the bottom right and multiply it by each digit going right to left of the top number. Right to left is a recurring theme in doing math by hand, doing arithmetic by hand. 3 times 4 is 12. Again, we can't fit the whole 12 in this place value, so we would carry the 1. Leave the 2, carry the 1. 3 times 4 was 12. Now we'll do the 3 by the second digit. 3 times 2 is 6, but we had this extra 1, so let's just add it on and get 7. Then 3 times 6 is 18. Technically, we just carry the 1, but there's no other digit there, so we can just put the 1 down. 1,872. It is important to be able to multiply by a 1-digit number. That's why you need to know your times tables, at least your 9 by 9, because if you could do 9 by 9, then you can handle any multiplication problem, such as 306 times 81. We're going to set it up as 306 times 81, but I'd like you to ignore the 8. In the last example, we just multiplied by a single digit. That's what we're going to start off with here. So we're going to ignore the 8. We're just going to do 306 times 1. So 1 times 6 is 6. 1 times 0 is 0. 1 times 3 is 3. That shouldn't be surprising. Anything times 1 is itself. Now I want you to imagine that the 1 isn't there. We're going to multiply by the 8. But since we're starting moved over 1 to the left, we're going to write our answer moved over 1 to the left. We're going to start writing it right underneath the 8. So to help us remember that, let's put a placeholder 0 in under the 6. That place is accounted for by skipping over 1 space. Then we do 8 times 6 is 48. Put down the 8, carry the 4. 8 times 0 is 0, plus the 4 we carried is 4. 8 times 3 is 24. Put down the 4, carry the 2, but there's no more digits, so we just write in the 24. We're not confined to not having space anymore. Then we add 306 plus 24,480. 6 times 0, or if you didn't put the placeholder 0 in, 6 times an empty spot, or 6 plus an empty spot, is 6. We are adding. We multiply to get the partials, and then we add the 2 partials together to get the whole. 0 plus 8 is 8. 3 plus 4 is 7. 4 plus nothing is 4. 2 plus nothing is 2. 24,786. I tricked you into using the distributive property. 306 times 80 plus 306 times 1. Whoops. Sorry, not sorry. The steps to multiplying the old-fashioned way are really just using the distributive property in disguise. Let's talk about finding the area of a rectangle. This rectangle is 12 inches by 4 inches. So we've divided it up into 12 spaces going left to right. into 4 spaces going up and down. If we were to count every one of those squares, we would get that there's 48 squares. The squares would be 1 inch on each side. So we call the 48 squares 48 square inches. This is the same as multiplying the 12 by the 4. Repeated addition is just multiplication. 12 4 times is 4 times 12. 12 times 4. 4 times 2 is 8. 4 times 1 is 4. 48 square inches. So we can multiply the length times the width to find the area. The state of Wyoming is in the shape of a rectangle whose length is 360 miles and whose width is 280 miles. Find its area. Well, length times width. 360 miles times 280 miles. If we do that, we line up the 360 and the 280. 0 times 360, get an answer. Move over. 8 times 360, get an answer. Move over. 2 times 360, get an answer. Add the 3 places, add the 3 partials together, being sure that you moved over 1 every time. In other words, 1 placeholder 0 on the second row, 2 placeholder zeros on the third row, and you get 100,800. And that's square miles, because remember, our visual. That's how many squares there are that are mile by mile long. You also could have done 28 times 36, 36 times 28, gotten 1008, and then added on the 2 zeros that you left off. I think I'd prefer to do it that way, because you'll notice your first row was a row of all zeros when you multiplied it using 360 and 280. So area is an example of a word problem that requires multiplication. Here are some key words or phrases that also indicate that it's a word problem that requires multiplication. None of these should be particularly surprising. Multiply, for example, multiply 3 by 4 means 3 times 4. Product, the product of 5 and 10 is 5 times 10. And times, 6 times 4 is 6 times 4. A particular color printer can print 21 pages per minute. How many pages can it print in 25 minutes? In other words, 21 pages 25 times the pages per minute times the number of minutes. 21 times 25. We do 21 times 25. 5 times 21 is 105. Move over 1, placeholder 0. 2 times 21 is 42. Add the partials, 525 pages. A professor of history purchased DVDs and CDs through a club. Yes, this is something that actually used to happen in the past. And before DVDs and CDs, it was cassettes and cassettes. Each DVD was priced at $11 and each CD cost $9. He bought 8 DVDs and 5 CDs. Find the total cost of the order. So if he bought 8 DVDs, that means he spent $11 8 times. And if he bought 5 CDs, that means he spent $9 5 times. 8 times 11 and 5 plus 9. And then we want the total, so we'd add those together. 8 times 11 is 88. 5 times 9 is 45. Add them together for the total, $133. If an average page in a book contains 163 words, estimate, rounding each number to the nearest hundred, the total number of words contained on 391 pages. So the exact answer would be the 391 pages times 163 words, because there's 163 391 times. Instead, it's a little bit easier, a lot a bit easier, if we multiply 2 estimates together, rounding each number to the nearest hundred. 163 words rounds to 200. 391 pages rounds to 400. 200 times 400 would be 80,000. 8 with 4 zeros. 2 times 4 is 8. And then 4 zeros that we left off make 80,000 words, which was a lot easier to get to, but again, is only an estimate. And that's it for this topic.